YouTube? It is time for another study vlog. Today we're going over Module 34, which covers recommender systems, and keeping in style with the Phase 4 format, I am doing this one with my dad. He is a career psychologist and not a career technology person, so the kind of goal for this is for me to make sure that I'm explaining things in a way that makes sense to him. So if I say something that doesn't make sense, he can stop me and ask questions. So if you're new to the channel, new to this playlist, what's going on here is I am currently a student at the coding boot camp called the Flatiron School. I'm in the data science program. I have just begun the 4th out of 5 total phases. Lean forward a little bit, Dad. Your face is disappearing into the blur. You're good. So I'm a student at the Flatiron School Coding Boot Camp. We're in Phase 4. I'm studying data science, and for every module in each phase, I do one of these study vlogs where I review everything that I learned in the module in a non-technical way. It is my goal to make practice my ability to communicate technical things to non-technical people, which is a skill that's pretty stressed in the curriculum at Flatiron. So, you want to introduce yourself to anything before we get started?
I'm Robert.
All right. So, we're going to go into the notebook now. So, like I said, all of Module 34 was covering recommender systems. So, when I say recommender systems, do you have any kind of inkling what that might mean already?
Well, I would, think that it meant collecting information or data in a way that helped recommend based on some other premise.
Yep.
Recommended.
Mm-hmm.
Yeah.
So, what's an example where you would guess that you've maybe encountered a recommender algorithm? Hey! Zeus wanted to make a special appearance. You encounter them all the time.
Yeah.
Like every night, for example, when you're in the living room. And you open Netflix.
Okay. Yeah. What program based on your previous history or something? Mm-hmm. They'll make a recommendation.
Right. So there's two broad categories of recommender systems. There's content-based filtering, so filtering in the sense that there's all these things that could possibly be recommended to you, and I'm having I have this filter where it blurs out the background and it keeps thinking that your face is the background.
Should I?
No, you're good. I think it's because your hair blends into the wall.
Oh. That I can do nothing about.
Yeah. Yeah, get a little younger for me real quick, though.
Yeah.
So there's filtering in the sense that there's all these things that could possibly be recommended to you. How do we filter out the right ones to recommend? Right. So content-based filtering is the most kind of naive approach. So it's, they might have a list of movies that are similar to a certain movie, and if you watch that certain movie, then they'll recommend to you, some movies from that list of similar movies.
Yeah.
There's not a whole lot of sophistication there, in terms of the code or algorithm or math behind it. So they can be great for certain situations. This is usually what you're running into with top 10 lists and things like that, where it's not really specific to you.
Just narrows down some of your options if you want to look for something.
Well, it's like if you watch say Saving Private Ryan, and then it might recommend some other World War II movie too, which is not really a lot about whatever information it has about you, so much as just the fact that this user watched this movie, and, So point being, there's not a lot of of your data being utilized with that type of
filter. Because in some cases you pick some movies because of the actors in the movie, not really, and it wouldn't know that. It would
correct, yeah. So a more advanced approach, which this is kind of the industry standard, so to speak, is called collaborative filtering. So basically, this will use the match your behavior with the behavior of other users, and by behavior I mean like what items they're like viewing or purchasing or like whatever, whether it's Amazon, Netflix, what have you, and they'll match like you with other users and recommend based on that. So like say if you purchased, you're an Amazon user and you purchased items like 5, 6, and 7, and there's another user that they've calculated is similar to you and they purchased items 5, 6, 7, and 8, then it will recommend to you item 8 because you are similar to that other user that also bought 5, 6, and 7. So that's a very like high level overview, but you can imagine there's some minutia to get into, and there's more specific ways of going about that. So it's a simple idea, but there's actually, it gets pretty complex in actual practice, right? So these recommender systems, usually they all use this thing called a utility matrix. You know what a matrix is from math, it's just like a grid of values. And for recommender systems, there's a certain type of matrix we use called a utility matrix. There's no like special properties about the matrix mathematically. The only thing special about it is that it's used for this purpose. So you see we have like the columns are like the items, and the oh, that's weird. They're using like famous mathematicians for the names on the rows are our users, right? So Bayes and Nightingale. These are all like mathematicians and computer scientists. That's funny. So you can see like Nightingale has not rated Toy Story, right? So all these users have different ratings for these different movies. That's what's like the 5, 3.5, 4.2 is.
Okay, so in other words, they rated the movie, didn't just watch it, but they gave some kind of rate. Okay.
Yeah, so you have, I think I have examples of this further down, but you have like explicit and implicit utility matrices. So an implicit utility matrix would be where instead of having all these numbers, you have just ones, and that only indicates like some Boolean feature. So like just whether or not you watched it. 1 if you watched it, 0 if you didn't watch it, right? Or it might just be like, you know how on Netflix you can give like a thumbs up or a thumbs down? Mm-hmm. It might be just like a thumbs up's a 1 and a thumbs down's a 0, right? So that's your implicit utility matrix. This specifically is an explicit utility matrix where you just like, you know that they watched the film just by virtue of there being a rating there at all, right? Mm-hmm. And then the value itself tells you like exactly how much they liked it. So those two different things are useful for different scenarios. Like if you have a viewer who likes Westerns, like period, you know, like they just like have put in their preferences that they enjoy Westerns or whatever. You don't need like an explicit matrix of all the different Western films of that user, like their ratings for each one of those films, because you know that they like Westerns anyway. So you just need to know which ones they watch. It doesn't really matter like exactly, you know, what the rating was for each one. So you would choose that because it would be like less computationally expensive. There's less math to do, right? So it's easier to do the calculation and make the prediction, right? So that's kind of like the dance I was playing as a data scientist, is like trying to figure out what's the minimum effective dose of calculation, basically. So this gray square here, you know, we don't have a rating for Nightingale on Toy Story. We don't know what Nightingale's.
Yeah, there are others that are blue but blank. What does that?
Those are also blank. They're just not the target current. Right now, we're trying to make a recommendation for Nightingale.
Oh, okay.
Yeah. So the other ones, you know, we'll get there eventually, type of thing. But at present, we're focusing on making We're trying to decide whether or not
Nightingale in particular.
Right. We're trying to decide whether or not to recommend Toy Story to Nightingale. Right. And so you might have some kind of condition where we only recommend movies if their predicted rating is over like 3. So with this matrix right here, we can approximate or estimate what Nightingale would rate Toy Story at based on like the rest of the information in the matrix, right? We can calculate like a rough estimate of what they might rate what they're most likely to rate Toy Story as. So if we made that prediction and it was like 2, then we would maybe not recommend that movie, right? But if we predicted that their rating would be, we're predicting what they would rate it if they were to watch it, right? So if we predict what that rating would be is like above 3, then we might recommend it. If it's below, we might not, or whatever your like condition is, right? That's another whole data science project in itself, is trying to discover like what the ideal like barrier is for like your recommendations. So you can imagine with the right kind of math, you could calculate what that gray square would most likely be, because you have like similar items and similar users.
So that's what you're trying to determine at this point, is what his rating, if
you were to watch it, what his rating would be. Versus if it was like an implicit matrix, you might be predicting like,
and if you were
simply if you would watch it or not.
Yeah, but if you were, that's just because that one is the one chosen. If you were going to try to see what his rating would be for Fight Club instead of Toy Story, that one would be the one that would be blanked out.
Right. Yeah.
Okay.
This would be gray, and this would just be
right.
blue.
Okay. So that's just the target.
Right.
Of far, not again. Okay.
And there's in reality, you would have some script that would run through and calculate all of these. You would write some code that would repeat the same process that you're doing for this gray square for like each one of these squares. Maybe if you needed that information. So there's 2 broad categories of collaborative filtering. There's memory-based and there's model-based. So we'll get into what model-based collaborative filtering is in a minute. Memory-based, what the memory word means here is that we're using the actual like raw utility matrix itself. So one of the drawbacks of memory-based is that there's a lot of data that you have to calculate. And one of the issues you run into is you'll have really sparse matrices where like there's mostly zeros or just like missing values, because not everybody has watched and rated every movie.
Right.
So that's why you have to like infer mathematically like what those values would be. When you're doing memory-based, there's I guess you can do this with model-based too, but you can 2 kind of general strategies. You can recommend based on the item. So like if this user likes this item and it's listed as similar to this item, then we'll recommend that item, right? Versus user-based, which is like if you have similar users and this user liked these 3 items, or these, and this user liked these 4 items, then we'll recommend that 4th one to that user also. So again, depending on what like the business scenario is, these are appropriate for different situations. So you might be wondering, how do you calculate or quantify how similar an item or a user is? So remember, this is all encoded in a matrix somewhere. There's some grid somewhere that's just a bunch of numbers, and statistically speaking, it doesn't matter that this is Toy Story. It just matters what the vector is. So you're going to have to rewind back to your trigonometry days a little bit here.
What the vector is in terms of the column and the row.
So you have these horizontal vectors and you have these vertical vectors. Right. So when we talk about we have like similar users, how do we calculate how similar those users are? If with thousands or millions of users, right, it would be inefficient to just calculate the like the correlation between like those 2 users. If you had like a column of each user and like all of their ones or zeros or explicit ratings or whatever, for millions of users that would just be way too much data to compute. Just doing it like one for one. So we do these fancy math tricks, and each one of these is basically a way of calculating, giving you some value that represents like how similar this user's matrix is to this user's vector. Is to like this user's vector. or for like items, if you need to calculate how similar this item's vector is to this item's vector. So this item's vector would be like all the other users' ratings about this item, right? And so then if this item has been rated similarly in aggregate by the other users, then we do this math and we'll discover that those items have been similarly rated. So all of these formulas you see here, they all, one way or another, will give you some value between -1 and 1. Or I think actually cosine similarity would be like 0 and 1. Okay. So I'm actually going to draw for you real quick. Let me. Okay, so you have a grid. Come on. Do the thing. Oh, that's frustrating. I can't. There we go. So you have some grid, right? And then you'll have a couple of vectors, right? So there's vector B, we'll call that. This is really hard to draw with my mouse instead of like my stylus pen. And then you'll have another vector A. Actually, that's a little more an angle. So each of these vectors has a like direction and a magnitude. The magnitude is like how long it is, right? So you have this angle here, which, if I'm remembering correctly, is denoted as theta. And then you have your tangent line, I think that's called. I need to go back and review my trig. But basically, your cosine similarity is going to approach 1 as this vector rotates and aligns with this vector B. And as it gets to, I believe, 90 degrees or so, it approaches 0. So imagine that these vectors represent like 2 users or 2 items like in our matrix. And this is like 2-dimensional, so you'll kind of have to put your imagination cap on for a second and imagine these vectors exist in like a hyperdimensional space. Like, you know, you might have 5, 6, 10, a dozen different dimensions. But nonetheless, they could be compressed into a 2-dimensional space, right? And so every column or row in that utility matrix can be represented by a vector mathematically, like this, where it has a angle and a magnitude. Okay. So when you're calculating how similar 2 users or 2 items are, you're basically calculating how closely these vectors lay on top of each other and if they're going in the same direction. Because remember, vectors have a direction too, right? So all those like weird formulas I just showed you, that's basically what they're all doing, is they're trying to figure out how closely each of these 2 vectors are to one. So that's all that is, just to demystify all the weird calculus. It's just trying to calculate what's the difference between these 2 arrows, basically. Back to VS Code. Oops. Okay, we're good. Yeah, so those are just different formulas of calculating the similarity between 2 vectors. That's all that is. And again, there's like different situations where you would use different ones of these.
Okay. That's when there's those three. Those are actually separate.
Yeah, you would
not one doesn't go into that one and then that
right.
one.
No. You would pick one of these formulas to
okay.
use. And you can tell that Jacquard similarity is very Bayesian in its influence, because this is probability notation, not calculus notation like the rest of it. Like you have this is intersect and this is union. That's like logical notation. But anyway, so that's memory-based collaborative filtering, and the problem with it is that you need the whole vector for each item or each user that you're calculating, and you have to calculate that whole vector, right? And that's just a lot of data. When you're dealing with like millions of users and millions of items, then it gets to the point where the computer just can't keep up.
Right.
Especially when you're trying to like make these recommendations like more or less in real time. So that brings us to model-based collaborative filtering, which this gets into like the weeds of matrix algebra, right? So basically, we take this matrix, and for whatever our target is, whoever we're trying to target, and whatever item we're trying to target, so whoever we're trying to recommend whatever like item to, we can decompose that into a matrix of just like of the user and a matrix of the item. And then we do take the dot product, which is a specific way of multiplying matrices together. And that will give us some value that gives us an idea of like how similar this user is to this item. So if like it's weird, like the idea of like a user and item being similar doesn't sound logical when you say it out loud, but you imagine like this user has a bunch of ratings of these different items, and this item is rated by a bunch of different users. So mathematically, there might be some similarity, right?
Yeah.
And that's hard to like visualize, but if you ruminate on it long enough, it starts to like make sense. But that's basically what the whole goal with model-based collaborative filtering is. You're trying to reduce the total amount of data that you have to compute, right? So that's why you'll decompose these matrices. Instead of using all this data, you might decompose it to just like the most important stuff. And when I say decomposing, that's in the same family that the principal component analysis I talked about last time. That's how we're taking 10 dimensions and turning them into 5 or whatever. Right. So you'll do like 2D composition. You'll decompose it according to user, you'll decompose it according to items, and then multiply those matrices together. So in the module, I don't know how important this is to like really explain to you, but the visual is nice at least. So we learned this thing called singular value decomposition, which for you is basically the same as principal component analysis. The implementation is different, the actual math and like the steps behind it are different, but essentially what you're doing is taking this really large matrix and decomposing it into a few smaller matrices that are, I think of it like when you're packing for a trip and you have your suitcase and you're like stuffing clothes in, you zip it up a little bit and you're kind of, so you can see we're kind of slicing like a little bit more each time. That's not a literal way to think about it, but like figuratively at least. So you kind of get the idea. You're trying to just compress all of this into like some smaller, more like digestible components. Alternating least squares, again, I don't know how important that is to really go over with you, but that's one algorithm that's used for doing this sort of matrix decomposition. And that's kind of what's visualized here is you'll have these specific types of matrices that you calculate from the parent matrix, and then there's a specific way to multiply these together to get your value. So with alternating least squares, what it's basically doing is you might you'll have like two sets of vectors that you want to calculate the similarity for, and they're too massive to do that calculation efficiently on its own. So it will take those two vectors and it will hold one constant and compress the other until it achieves like some value, and then it'll hold that one constant and then compress the other, and it'll keep doing that until they arrive at what's called convergence, which is basically like when those two vectors are equal to one another. So that's basically like preparing the data to then do the calculations, compressing it. But we don't want to just completely compress one vector, because then we might lose some information that's necessary to properly compress the other vector, right? So we just kind of alternate back and forth until we arrive at what's called convergence. So that's alternating these squares in a nutshell. So, recap. We have memory-based collaborative filtering. We have model-based collaborative filtering. We also have content-based filtering, which we talked about as kind of the most naive approach. And it's great for if you're trying to recommend like top 10 lists and things like that, but it's not really useful for making specific recommendations to a specific user, right? So we use collaborative filtering for that, and there's a couple different ways to do that. We have memory-based, where we just use all the data, and if we have the computational horsepower to do that, that's great. But at scale, that becomes difficult and timely. So then we use model-based collaborative filtering. And the word model is basically referring to the fact that we first compress the data, and then we build a model based off that compressed data, and we make predictions with the model. Versus with memory-based collaborative filtering, we're just calculating correlations, basically, between two different vectors, right? With model-based collaborative filtering, we're actually manipulating the data and building a machine learning model that makes predictions on that data. So it's a little bit more sophisticated in the sense that you have to go to that trouble to find out what's the best compression method and the best model and all that. But once you have that model built for a given database, then it becomes very efficient in making the predictions. You just plug in a few inputs into the model and it spits out like a recommendation. So, any questions, comments, concerns?
Well, the probably the place that I'm most fuzzy about is when you're discussing or talking about you compress the data back and forth until they converge. I'm not sure I understand how the filtering process takes place to give a specific usable information about that, because it's sounding to me like you're just taking the data and making it converge into something, and when it converges you're using that. But I know that it's really targeted in some way, and I missed somewhere in there how that process is taking place.
So you're compressing it for the sake of reducing your computational cost when you calculate the recommendation. So you're taking a couple vectors. When you're doing the alternating least squares, you're squeezing them smaller and smaller, but you have to do that like a little bit at a time for each one to make sure that they stay. There's some like mathematical relationship between the two of them in the beginning, right? And you want to maintain like the truth behind that relationship,
right? And
so that's why you have to kind of like alternate back and forth. And so what you end up with is two much smaller vectors that still represent the same information.
Right.
So then you can calculate the correlation between those two smaller vectors a lot quicker and a lot easier than you can with the original ones that were much more massive.
Okay, so it's like beginning an a priori. You have your starting point and you go from there. Yeah.
Right. You're trying to it's an optimization problem at that point.
Right. Okay.
Yeah.
That makes sense.
So
Cleared that.
One thing that I'm hoping you're getting out of this is like everybody's really weird nowadays about like their data being collected. But one of the things that like this module made really clear to me, we don't really need this anymore, is your data is kind of useless outside of like the aggregate of everyone's data. So everybody's like, oh, they're taking my data and they're going to be like monitoring me, like doing all this stuff. That's a very self-important way of like thinking about it. And the reason that they want everyone's data so rapidly is because, not because they want your data, but because they need a body of data. Right?
Yeah.
And so the more I learn about this sort of stuff, like the less concerned I become with my data being collected. I'm still a little concerned because like they could like end up like, you know, the technology exists that they could monitor you specifically if they wanted to, but what I'm getting at is that that's really not what they're interested in.
Right.
You know,
right.
They just want your vector in their matrix, basically.
I mean, what I guess the way I would break that down is, if for some reason there was, and it would really, let's say the government wanted to identify certain characteristics of the population that had some meaning to them that they needed to do something with, then they could design a way to identify certain people and gather data that would they could go, well, we need to.
You could definitely build a model that predicts like certain behaviors.
Yeah.
Right.
Yeah.
Like that's one way that they started. When data science really started was it was some statistician working, I forget exactly where, but like working for some police department. They were trying to catch like a serial killer, and he used statistics to predict like where the next location is. They didn't know anything about the guy. They didn't have any personal information about him at all. But based on the physical locations where he had previously struck before, they were able to predict like roughly what areas he would like strike in again. Right. So likewise, you know, they could definitely build models that would predict. One thing that I think would be really important is if they built something that could predict if somebody is at risk of becoming an active shooter based on their social media posts.
Right.
Because it seems that's always the thing. You get like some active shooter, and people go back and look at their Facebook, and it's like, oh, look at all this weird shit. Right. You know, he was like, you know, posting.
Exactly.
A lot of them like literally post on Facebook, I'm gonna go, you know, shoot this school or whatever. That's definitely like an application of data science that I think is going underutilized. You could certainly, if the data was able to be collected, you could pretty accurately predict who's at high risk of that kind of behavior. Or like, you know, even less like tragic things that you could predict who is maybe at risk of an eating disorder. You know, like young girls becoming anorexic or whatever. You might be able to predict that based off not their own social media posts, but the comments that they're receiving on their posts.
Yeah.
If you could collect that data, then you could look at, you know, you could build a model to predict, like, you know, who is going to likely become anorexic because they're being exposed to like a certain vector of like comments.
Well, I would think maybe too that if you had all this data that you could say this looks like active shooter kind of profile, that because of all this compression and things that you're doing, that it would be hard to take that and then find that individual that all went back to. You would have to have a target to see if it fit their stuff.
So you would build a model that would be designed to predict like a platonic active shooter. Right.
Yeah.
And then you would
have to.
So every model basically is making a prediction in some way or another. You build a model, and then once it's built and developed, you give it some inputs, and it gives you an output.
Okay, but based on that last segment that we did, that would then be able to filter down and see who matched out of all of that. You'd be okay, so you would be
So
able
like
to
the inputs to the
determine
model,
who was matching
right?
this, and
You would have like
go
some
from there.
platonic, within the model, there's like a platonic profile of like an active shooter or a person with an eating disorder, whatever the thing is, right? And then you would take like, in this example, their social media posts as the inputs, and then it would spit back out like basically yes or no.
Who would
Or it would give you like a scalar of like they're 10% likely or 60% likely,
right?
Like whatever.
And so then, like, let's say if it was the ATF or somebody trying to figure out who these potential risks are, then they would be able to, then that population would become a target that they would kind of monitor to see if it was leading closer to a high risk.
And that's where you get into like the privacy issue of like, like how much monitoring is really ethical in that sense, and like how much are we really like it's a weird thing for people to get comfortable with like a computer predicting that they're gonna be like a bad guy or like something. People don't like to. People like to think that we're sort of like transcendent from like computers. You know what I mean? Which the reality is like we made the computers, right? And so they're kind of components of us rather than being like a different thing. And the other thing is like, how do you like once you have those predictions, then how do you deal with it? You can't have the ATF rating you just because like some computer model.
Exactly.
Like so.
But what happens is if this person went out and shot, then there's going to be someone blaming those that had the data that they didn't do something.
Yeah, so you get into
like,
that's kind of the strife of the data scientists is like the technology is there for this sort of stuff, but it like figuring out a way to like ethically and responsibly implement it is the problem. Like our ability to make these kind of predictions and things is like pretty well established, but our ability to actually like take action based on them is the issue. And it's always it's a communication thing, even if in like less serious situations you're just trying to like recommend like if you should market this product harder or something, that's still like you're having to communicate technical information to a stakeholder. You're trying to convince somebody to take real world action based off of some weird math stuff that a computer did. You know what I mean? But yeah, recommendation systems in particular, we encounter them every day. Anytime you shop on Amazon, anytime you log into Netflix, even when you open Instagram, like it's using a recommendation system to pick what the next piece of content is that it's going to put on your feed. You can imagine, think about how many different things you've like liked or not liked for that matter, or clicked on and then not liked, and all that stuff has to be fit into a matrix somewhere. That data gets pretty big pretty quick. Right? And so that's why we can't just use memory-based predictions. For small data sets, it's fine, but for something like Facebook deciding like what the next post to put on your feed is, and it has to make those calculations like pretty quickly.
I'm assuming it's doing that from what I see on mine. The ones that I push like on a lot keep showing up. Like for instance, I somehow one just popped up. This is the first time I'd ever seen it, but it was like on musicians, a little deal on Jimi Hendrix. Well, I pushed like on it. Now I'm getting
just a ton of Jimi Hendrix content.
Not Jimi Hendrix, but different musicians from the '60s, really.
Oh yeah,
from that era.
Because those are similar items.
Yeah. And but they're all neat, so I keep pushing like on them because I want to get new ones that are similar. So
so that would be item-based collaborative filter.
Okay.
Because it knows you like this item, so it finds similar items and then recommends those.
And there were friends that I used to, get their whatever show up on my Facebook, their post or whatever. that don't anymore, because I would just look at them sometimes or scroll down
Keep
through
scrolling,
and didn't
yeah, you have to.
didn't set on it or didn't push like on anything,
Right.
and they just kind of fade away.
Yeah, so it rewards most of the social media algorithms. They reward interaction in some way or engagement, like in some way or another.
Okay.
So that's like, if you like it, maybe that's 1 point. If you comment on it, maybe that's 2 points. If you share it, maybe that's 3 points. Maybe it's 6 points if you comment and share it. There's like a hierarchy of different interactions you can have
And
with
there's
it.
some that I actually save because
Mhm.
I want to go into that and find those again pretty
Mhm.
quickly.
Mhm.
And so I'm assuming that would be a big point.
Right. Yeah.
Yeah.
Yeah. You have to. There's too many people paying money to get their content pushed onto your feed. So if you want to keep seeing like just your personal friends like on Facebook, you really have to like engage with their content, or Facebook's going to interpret that as you're not interested in what they're posting, so they're not going to show it to you.
Yeah.
Because their whole deal is keeping you on the app and active on it. So they're trying to feed you stuff that you're going to interact with.
Right. Okay. So
Yeah.
if there's someone in particular that I want to see more of their posts, I need to
You need to
interact
like it.
with it.
Yeah. Comment on it, something.
Yeah.
Yeah, and that kind of gets into my deal. Like I said, their whole incentive is what they're trying to get out of you is your time and attention, right? And that's how they make their money, because the more time and attention they have, the more of your time and attention that they have on their app, the more valuable their app becomes to advertisers.
Yeah.
That's how they make their money. Is people pay them to have their advertisements show up in front of you, right? And the only way like Facebook or Twitter or whoever can make the argument that it's worth spending money on their platform is if they can show that we have X users spending X amount of time engaging with this content in like a certain way. So I would like to see somebody conceive a business model for social media where the incentive becomes not the business incentive for them, for the company, becomes not just time and attention, but if this would be like tough to quantify or even qualify really, but instead of like like getting more of your time and attention, it increases your sense of fulfillment or joy or something, you know, which isn't necessarily correlated with the time that you spend on the app. It might actually be negatively correlated depending on the content that's like on the app, you know. But if you were able to have if you were able to like build some social media platform and show people that, hey, even though people spend 1/5 of the time on our app as it does on other people, they're like, you know, 150x more satisfied, or, you know, 150x more like, you know, like joyful or whatever from our app than users who spend the equivalent amounts of time or greater amounts of time even like on other apps. And then that's valuable to advertisers, where they go, okay, well, we're not going to get as many hits on our ad, but we're probably going to be more likely to convert on those ads that we do get hits on, because those people are more joyful. Right. So that's what I would like to see, is like a kind of paradigm shift from time and attention to fulfillment with the social media apps. And I think if somebody was able to figure that out, then we would see a lot less kind of negative influence of social media on society at large, and like our own just kind of temperaments and moods and things. You know, people are really just kind of like catty nowadays because they're spending a lot of time on social media, so they're just constantly like pissed off because they saw some stupid person post some stupid thing that they disagree with, and they spend the rest of their day huffing and puffing, and they get back on social media and they bring that same energy, and then, you know, and it's just like this whole like self-perpetuating like cycle of negativity. I think if we got away from the time and attention paradigm and towards like a fulfillment paradigm, then that would probably address quite a bit of that, at least. Not completely fix it, but I think that would be a significant step in the right direction.
Well, because there's no complete fixes, I don't think.
Yeah, no, you're always going to have mean people being jerks.
It's like if you want peace of mind, you can gain that yourself. But it's not going to be because the world has become a peaceful place.
Right.
You know? So, and for you to know that you have peace of mind is probably because you know
right.
the
the
world is not at all at peace.
But we could at least create environments where creating lack of peace isn't incentivized, which is basically the case with a lot of social media nowadays.
Yeah.
Like the time and attention thing, the best way to... Whoops. My computer went to sleep. Because I wasn't clicking on it, I guess. What was I saying? Yeah, so the time and attention thing, like the most potent ingredient for time and attention is things that create generally negative emotional reactions, right? People are going to spend more time on something when they get, into some like argument in the comment section than they are. They see something that's really cool and makes you like, go like, oh wow, like there's such great things going on in the world. You're just gonna like that post and keep scrolling. Yeah. Versus something that like really gets you going, and like angry and upset. You're gonna spend time commenting and arguing back and forth and stuff. So we could at least like create an environment where like that is sort of maybe not as much of an incentive. At least it's still going to be a factor or like a feature of the model that exists, but we could at least make it not the reward system.
Yeah, exactly. Because I think that's one of those things you have to do personally, though. Somehow, is to get that kind of negativity. I mean, it's like you become addicted to it in a sense.
Right. Yeah.
You gotta find ways to dissolve that from your system.
So I'm curious, as a psychologist, do you have any unique thoughts about recommendation systems in particular, and how that might influence or affect us?
I don't see how it can be any different than the way it's based in terms of gathering information and data. Because you I mean, how else could it be done?
Well, I mean, like about like the impact on an individual that's being exposed to one of these technologies.
I may not be following you exactly on that, but
well,
I don't see I could. I think that a person, if it's feeding you stuff that your behavior through interaction with the computer or whatever it is doing, then you're creating, in a sense, what it's feeding you, and so it doesn't know how to say, well, let's try to change this person's focus from negativity to being more positive and feed him something. It has no way. It doesn't have the mind to do that. So it's always going to just feed you
whatever you're
what you're connecting with.
Yeah, if you tend to like things that make you angry or something, or just interact with things that make you angry, it's just going to show you more things that make you angry. Right. So I guess if you were if you had to counsel someone and their issue was this recommendation algorithm to keep interacting with, what kind of advice would you give to somebody to minimize its potentially negative impacts and and optimize for the positive impacts that it might have on it? If you're just giving someone advice on how to interact on social media with the awareness that these recommendation algorithms are going on.
I mean, the only thing I know is, let it go. Don't engage with the negativity. Know that it's there, recognize it in yourself, but let it go. I mean, because what you're doing is, negativity, if you have negativity, there's certain neural pathways in your brain that are firing, and they get stronger the more you become habituated to those things triggering and that negativity. And so you can't focus on that thing without firing those neurons that make them stronger. So you have to just let it go and go to something else. You have to know it's there.
So in practice, that would look like just keep scrolling instead of interacting.
Yeah.
Mm-hmm.
Understand your feeling about it, know what you're feeling about it, and then let it go. What happens then is you're not strengthening that neuronal connections, and so it's weakening, and so your focus can then go to other things, because if you focus on that, you're focused on that. You don't have energies that's focusing somewhere else.
Right. So the real solution isn't to try to like play the algorithm to give you more positive things. It's just to simply be a little bit more positive.
Yeah, and I mean that this ancient wisdom has been trying to convince people of that for thousands of years.
It's really not new. Like we've kind of been knowing that. Yeah. That might be like now that I'm thinking about it, like kind of up and coming like discipline within psychology or even like social work, just like guiding people on how to navigate social media in a way that doesn't like negatively impact them. So as a counselor, you're kind of giving people advice on how to go about their life in ways that like optimizes positivity and minimizes negativity, generally speaking. Right. So now we have this whole new dimension of our lives, social media, which has become kind of pervasive. So I imagine in the future, there might be people that's like what they do is they counsel people specifically on how to deal with social media.
And that would be good, because you think a lot of people reserve their negativity from their close relations because they don't want to mess up that relationship. It may be one of the few relationships they have, and so they're not wanting to destroy
the relationship with a person or with
a person. And then so on social media, it's easy to call someone an idiot or whatever, and so you get it's not just cathartic, but it can be it's like programming a system of thought, or behavior and emotion that's in your body that
you start getting like kind of overconfident because you can get away with a lot of stuff that you can't really get away with in real life.
Right. And so the danger that I see in that is the physiology. I mean, it's known that that's destructive to your health. All that negativity and prejudice and hatred and those kind of things, that your body follows your thinking and beliefs in that system, and it's unhealthy. So it could be that a lot of people are actually creating more problems for themselves than they realize. They go off and they have a health issue and they don't even know that it's maybe connected with something they're doing. And most people, when they have health issues, it's almost like, this just happened to me. They don't realize that it's a part of them. It has something to do with them. It didn't just fall out of the sky into you. It has something to do with your relationship with people, or what you eat, or the world, or your thoughts,
or just like something. Your average mood throughout the day.
Yeah.
When I was personal training, I heard this analogy that was really interesting to me. They explained that, I think it was a physical therapist who followed on Instagram or something. They explained like most people think about their health like a machine, like you think of a car. Like you were saying, people think, well, this just happened to me. Kind of like we think of like, well, eventually you just have to change the tires, like on a car. Eventually there's just stuff that you eventually just need to. It's just going to break down and you deal with it. But this guy explained that we're not machines, we're organisms. Right. And so a lot of times we're like, something's wrong, we try to fix it the way like on a car you just bolt it on and replace a part, like bolt it back on, and Bob's your uncle. When in reality it's really more like gardening, or like raising like a flower or something. If something's wrong with it, you have to change the environment, and then it sort of like adapts to that new environment. Right. So if it's not getting enough water, you add more water to the environment. If there's not enough nutrients in the soil, you put richer soil in the pot. Whatever. If it's not getting enough sunlight, you move closer to the window. Like whatever, you do stuff to like, you don't actually like cut the leaf off and like sew a new one back on. You know what I mean?
Yeah.
You change the environment so that leaf becomes like revitalized.
I think that using that analogy with the environment, to me, is like it becomes clear that, most people think life is, I have it in me.
Mm-hmm.
I'm alive. Life is in me.
Mm-hmm.
But the truth is, life is really a relationship within an environment.
Yeah.
If you go sit on the moon without an environment that you're sitting inside of,
You're out of here.
You're gone.
Yeah.
So life isn't in you; it's a relationship
With the things around you. Yeah. Yeah. Nowadays, social media, streaming platforms, all that stuff has become part of our environment.
Right.
And now we have these recommender systems that we interact with that makes that environment more of what we interact with the most, which is kind of like a double-edged sword.
Yeah, it's kind of providing a mirror image, really.
Yeah.
Yeah.
Yeah, versus like in real life, I guess if you do things that are bad for you, you get like a negative response. You know what I mean?
Yeah.
And so then you kind of, that sort of like life in general sort of tries to like pull you away from things that are harmful.
Right.
You smell a bad smell, you retract from it. You feel pain, you retract from
Yeah.
it, right? And that happens like at a little bit more like meta level too with our behaviors and stuff like over time. But it's kind of the opposite case once you get on social media. Once you have an interaction that's like harmful, the algorithm thinks that it doesn't understand that it's harmful. It just understands that you're interacting with
that you like it. Yeah, you're engaging.
Yeah.
And you want to keep engaging with it.
Right. Yeah. No, it doesn't even have a sense that you like it or not. It just has a sense that you're interacting with it, and that's the reward. Is it wants to give you more things that you'll interact with more, because it's trying to keep you like on the app for longer.
Well, it's like the rat in the little box that you could get food or you can get a drug. The endorphins or the dopamine and stuff that make you feel, and the rat would starve itself and keep getting the dopamine, the drug, for the pleasure center instead of eating. So we are easily programmed, or can program ourselves to move away from anything that's difficult or not so fun toward something that is pleasurable. Yeah. And you have to balance that.
Right.
And sometimes you have to learn.
And I guess that's
balance that.
Like my thing is like we need to shift from like getting in an argument on Facebook or Instagram in the comment section or whatever, and like even though it might get you like riled up and angry, it's still pleasurable in some sense.
I think you're feeding your ego.
Yeah.
When you do
right, but that's still like it gives you some sense of pleasure.
Yeah.
Right.
Right.
And,
exactly.
And that's my thing is we need to move away from like something that like prioritizes giving you pleasure and something that prioritizes giving you fulfillment.
Yeah.
Because like I've probably told you the analogy before. Jiu-jitsu is fulfilling to me.
Yeah.
Partly because it's hard and it sucks and it's painful and uncomfortable at times, And so going through that and still doing something cool or like seeing myself get better despite all like the suck, that's fulfilling to me. Right. It doesn't give me pleasure, but it does give me fulfillment. Yeah. And if we could figure out a way to package that sort of relationship into an app, I think that would improve a lot of things.
Well, there's a thing, pain and pleasure, two parts of a grid in a sense, and there's pain that is destructive to you, and then there's pain that is growing, and both of them
likewise for pleasure
feel the same. The growth of pain is just as difficult and painful as the pain of self-destruction.
The difference is the context in your mind.
Right. And it's the same way with pleasure. You can drink yourself to death, so that pleasure is killing you. Or you can do pleasurable things that are because you're growing, like you say, the fulfillment may be more than pleasure. It's more fulfillment. Right. And if you get the two lined up, the pleasure or fulfillment and the pain of growth
Mhm.
in the same quadrant, then you're moving forward.
Right. That'd be a good visual to put together.
I have that I
Do you? Okay.
wrote a long time ago. Yeah, of the
We'll have to
choices grid is what I called it.
We'll have to
Basic choices.
take a photo of it and put it on the stream sometime.
Cool. Yeah.
Cool. Well, that is my computer telling us to wrap it up.
Okay.
That's about an hour, so that's probably a good place to wrap it up. This will be a fun.
Oh, that was all a part of that deal? Okay.
Yeah. Yeah, it's just been recording us the whole time.
Oh.
Yeah, the screen
really?
share and everything.
On that thing about your program.
See, all I got to do is I have it set up, so all I got to do is click this button, and now it has us in the corner here, and the screen is what you're seeing on this monitor here is part of the frame that's being recorded now.
That was sort of like we were doing a podcast on something.
Right. Yeah.
Yeah.
Yeah, this was good. We actually kind of got into. We didn't really the last one. We really kind of got into like the crossover of like your profession and my soon-to-be profession.
The melding of the data
Right.
science and just the psychology behind some things and stuff. Yeah.
Yeah. So that was
pretty cool.
That was fun. That we like not only to just give you some information about this, but we were able to kind of like dig into like the implications of it.
Yeah.
So hopefully we can kind of keep up that trend like through the rest of these vlogs.
Cool.
Yeah. And maybe get Mom in here too, because she's also it's like y'all are same generally same education, same profession, so she would I'm sure have
and that would be very different because her training is more in the clinical
like she's like
area. Mine's more in the philosophical, how to make your life better.
Right.
If you're, coming to a counselor because you just want to learn how to deal with your anger and stuff, and hers is more people that are crazy. And,
you're more like the soft psychology. She's the hard psychology.
Yeah, exactly.
Right. But yeah, because I was showing her like the confusion matrices and stuff, and she was like, "Oh yeah, I remember that from grad school."
Oh, yeah.
And I was like, "What?" But that makes sense. And what I'm starting to realize is what I'm doing as a data scientist. A lot of it is the same. It's the same that any kind of academic researcher does in the analysis stage. But the thing is, there's just so much data out there now that just like we used to have just like philosophers, and then they started specializing as like biologists and physicists and chemists and whatnot, and that all started as philosophers. Yeah. Right, and they got into these like specializations, and so now data science is just kind of like the next specialization from that like root of philosophy.
Just think about before the computer, if you were going to do research, you were limited to the time that it took you to whatever data you could gather and the calculations that you could do if you wanted to get it published in your lifetime.
Right.
You had to limit it to know. And now with the computer, man, you can put so much data and stuff.
Now we can do calculations in minutes that would actually take lifetimes to do by hand.
Exactly.
So that's cool. All the stuff I'm learning is the same stuff that I was kind of referenced to when I would take like biology class and stuff in college, and we would do the statistical analysis. Is I'm just doing that sort of stuff, but just specialized. On like it's like whatever kind of data it is, I can do data science on it. You know what I mean? So like that, I started to realize that when Mom was like looking at the confusion matrices and being like, oh yeah, I remember that, and then it started clicked like
some of the models of
all this statistical stuff that I do. The programming is completely unrelated, but the statistical concepts and the statistical tools that I use is the same stuff that they use in academia, like for research. It's just there's so much data out there now that just like we had to have specialists for different disciplines of science, now we have to have there's a new discipline in science that is data. So
it's sort of like once Newton discovered and developed all this mathematical stuff, other fields were able to take parts in some of that and apply it in their own special areas in a way that everything just kind of grew. Right. Yeah.
Cool. So that's probably a good place to wrap it up at. If you made it this far in the video, I really appreciate it if you give it a like, and if you're interested in more of this sort of stuff, obviously subscribe to the channel, turn on notifications, and you will see the next one, if you're curious about, if you want to look through the GitHub repository and see like all the different notebooks and labs I'm doing in this boot camp, there's a link for the GitHub below. If you have specific questions for me, if you want to talk to me directly, you can connect with me on LinkedIn. Also, URL is below. And if you're curious about the Flatiron Bootcamp and what kind of programs it offers and what the curriculum might look like, also, I'll have that link down below as well, so be sure to check that out if you're considering a career in data science. So next time we'll be going over Module 35, which I don't even know what the topic of that is, but we'll be here for it. Dad will be here for it. So yeah, we'll see you guys next time.